Hi, welcome to the continuation of Chapter 4, Overview Part 3. We are doing today 4.4 Oxidation and Reduction Reactions. So the topics that we are going to discuss in this short video is we're going to define oxidation and reduction, list the rules for determining oxidation numbers, and then discuss that redox reactions occurring, how redox reactions occur in single displacement reactions, and then finally determine if a single displacement reaction will occur. So what are oxidation reduction reactions? First of all, remember, we discussed this over the summer. They occur at the same time. So when you have a reaction, if something's getting oxidized, something else must be getting reduced. And oxidation is the loss of electrons. So if you're losing electrons, the charge on your substance will increase. Reduction is the gain of electrons. So if you're gaining electrons, your charge will reduce, hence the name reduction. Again, one cannot occur without the other, and we normally refer to these as redox reactions. In order to determine what is being oxidized or reduced, we must look at the oxidation numbers. So we have to assign oxidation numbers to the elements in compounds. Okay, this is sort of a bookkeeping method. It does not imply that the atoms have those actual charges. So for example, in covalent bonded substances, we assign charges to the elements in those molecules, but they do not necessarily have those charges. So here are the rules for assigning oxidation numbers. Remember, elements in their standard state, elemental form, always have an oxidation number of 0. That goes for your diatomics also. Your oxidation numbers of a monatomic ion is the same as its charge. And nonmetals usually have negative oxidation numbers, although they sometimes can be positive. Most of the time, oxygen is -2. Unless it's peroxide, then it's -1. Hydrogen will mostly be +1 unless you are bonded to a metal. If you're bonded to a metal, then hydrogen will be -1. Fluorine is -1, as well as other halogens are usually -1, unless they're combined with oxygen. Then they will be positive. And in a compound that is neutral, the sum of your oxidation numbers must equal 0. Or if you have a polyatomic, the sum of the oxidation numbers must equal the charge on the polyatomic ion. Single displacement reactions are examples of redox reactions. So in your displacement reaction, one compound, one substance is getting oxidized and the other one's getting reduced. In the diagram shown here, you have HCl plus Mg yields H2 plus MgCl2. So your elements and your diatomics have a charge of 0. Then you go and assign charges to everything else based on the rules we just discussed. And you look at the substances that charge increases was oxidized. So here, magnesium was oxidized. And the substances whose charge decreased, in this case hydrogen, was reduced. So let's do an example. Let's write the molecular and net ionic equation for the reaction between solid copper plus a solution of silver nitrate. So that's aqueous. So this is single replacement. So the copper is a metal, so it will switch places with the metal here. And let's assume that we are going to form copper 1 nitrate. And then you have your silver metal. So here is your molecular reaction, and it is balanced. Now we're going to write our charges on top. Nitrate as a whole is -1. So that's a spectator ion, so there's no need to assign charges to that. So now let's write our net ionic equation. So as I said before, your nitrates are your spectator ions. You can get rid of that. So your net ionic equation here is as such. So which substance was oxidized? Which substance's charge increased? So by looking at this, you see that copper solid went to copper +1. So that was oxidized. And conversely, silver went from +1 to 0. So that was reduced. So in this example, they're assuming that you had copper 2 nitrate, where we did copper 1 in the previous example. So you see here they came up with a similar reaction, except there was a 2 here from balancing. So let me just write that here so you see what I'm talking about. They assume that you made copper 2 nitrate. So when you balance that, you end up with the 2's there. But this here is your net ionic equation. And if you look at the picture here, they're putting copper in silver nitrate solution. You see that a white kind of precipitate is forming on the copper, and there's some bubbles forming. So that white stuff that you're forming is silver, and then you end up with copper nitrate in solution. Now, can the reverse happen? If you had a copper nitrate solution and you put silver wire in it, what would happen? Well, as it turns out, nothing would happen, no reaction. So the reverse cannot happen. And how can you tell whether a reaction will occur or not? Well, you have to use the activity series. And if your single element, so in this case, if copper here is higher on the activity series, than silver, then the reaction will occur. So, but what actually, so you have to compare copper and whatever it's replacing, silver. And for the reaction to occur, the single element has to be higher on the activity series than the one in the compound. Okay, the element higher on the activity series will be more reactive, and they will end up existing as ions when the reaction occurs. The element below will end up being an element. So let's look at the activity series, and we were doing copper and silver. Copper was our single, so our reaction was copper plus silver nitrate. So you see copper is higher than silver, so the reaction will occur. The reverse will not occur. This will react. Also, if you're putting metals and acids, so here we have hydrogen. If your metal is higher than hydrogen on the activity series, it will react to produce hydrogen gas. So if metal is higher than hydrogen. It will react and it will bubble and produce hydrogen gas. So let's summarize what we covered in this short video. Oxidation is losing electrons, so the charge increases. Reduction is gaining electrons, so the charge reduces. The oxidation numbers are assigned to determine which substance is oxidizing or reducing. And single displacement reactions will only occur if the single element is higher on the activity series. Okay, that means it oxidizes easier and the reaction will occur. All right, if you have any questions, let me know.